Okay, for what we have in problem number 24, okay, we have in reference to errors on a typing test. Okay, now for the numbers here, we have class B in reference to the number of errors. Okay, so you have ranging from minimum of 0 to 2 to a maximum of anywhere from 12 to 14. We have the corresponding frequencies of 1, 3, 4, 1, and 1, where we have a total of 10 typing errors. Now, in the context of constructing what the mean is going to become, okay, again, we have to revert back to, since you do not have the data itemized, we go back to the use of the midpoint. Okay, so for the class midpoints, okay, we have between 0 and 2, we have 1, and since we have a class width of 3, okay, transition from one lower class level to the next, upper class limit to the next. Actually, I was supposed to be one lower class limit to the next, upper class limit to the next, and one class midpoint to the next. Okay, we had to be at 3, so we have 1 to 4 to 7 to 10 to 13. And in the setup to determining the class mean, okay, have a column once again for the product of the frequency of the midpoint. So 1 times 1 is 1, 3 times 4 is 12, 4 times 7 is 28, 1 times 10 is 10, and 1 times 13 is going to be a 13. And in the case of what we have in the determination of the variance as well as the standard deviation, again, you're looking at the frequency times the square of the midpoint, and you can arrive to this set of numbers, okay, from taking the product of the last two column values for each row. So you have 1 times 1 is 1, 4 times 12 is going to be 48, then we have 7 times 12 is 196, 7 times 28 is 196, 10 times 10 is 100, and 13 times 13 is 169. Okay, so for what we have in terms of the setup, okay, now we have for the total of the values, okay, that we have for the product of the frequency and the midpoint. Okay, we're going to have, okay, for that sum, okay, that is going to be at 64. And as for taking the sum of the products of the frequencies and the square of the midpoints, okay, for that particular number, okay, that is going to be at 514. Alright, so for what we have in the case of part A, okay, for the determination of the mean itself, okay, so we have 64 for the sum of the products of the frequencies and the midpoints divided by the number of items, in this case the total number of typing errors. So for the mean value, okay, that is going to be at 6.4. And now in the case of the next item, okay, we have for the modal class, okay, there'll be that which corresponds to the highest frequency. In this case, highest frequency is going to be 4, so the modal class is going to be 6 to 8. In the case of what we have for the variance itself, okay, again, we have our multivariable expression. So you have n times the sum of the products of the frequencies and the squares of the midpoints. And then we have minus, again, the square of the sum of the products of the frequencies and the midpoints. And again, have divided by n times the quantity of n minus 1. So in the lead into the determination of the variance itself, okay, again we have for s squared, okay, n is going to be at 10, and then we have times 514. You have minus the square of 64. Then we have 10 times 10 minus 1, or 10 times 9. And so for what we have, so we have what's going to be 5,140 minus 4,096. Okay, so that is going to be 1,044 divided by 90. Okay, so in the case of the variance, okay, that's going to be at 11.6. And so with our sample standard deviation, okay, that is going to be the square root of the sample variance. So you have the square root of 11.6. And so for that number, say we're to take this out to the nearest two decimal places, okay, we have about 3.41. Okay, so we have in sum, okay, we have our columns arranged. Okay, and again, the mean we have at 6.4. Modal class again is 6 to 8. And with the variance, taking our 10 typing errors and looking at the data we have concerning the frequencies and the midpoints, and substituting accordingly and calculating. Again, we had the variances at 11.6, and we had the standard deviation again is about 3.41.